Awesome. Let's go. Right. Just double check the audio is coming through. The last stream with some problems. Don't know how delayed I am. But let's see. Oh, it's muted. Right, it seems to be working. Cool. So, last stream, we were getting the... it was refactoring the code such that we could do layered materials. And so we've written CPU side, all of the material layer stuff, basically. So you can basically... where is it? Graphics. Yeah, so we've got like three in the code base now. We have geometry materials, detail materials, and blend materials. So we're just going through trying to get it up and running now, and then we should be implementing detail materials, which allows us to obviously, as implied by the name, add more detail, more sign distance field shapes on top of some piece of geometry. Basically, that's what it is. So we'll be doing that hopefully today, and hopefully getting some good progress done there. So yeah, start with a quick prayer and then we'll get going. Dear Lord, thank you for this day. Thank you for providing us all the things that you provide us, Lord. Thank you for our health. Thank you for our family. Yeah, thank you for all the jobs you've given us to do and the tasks you've given us to do on this earth and all the abilities and the skills that we have. Thank you for that, Lord. But yeah, just pray that we have a good stream today. I pray that it's a successful stream and we're going into areas of which where it's going to yield fruit for the final thing. We won't be going off down some rabbit hole which doesn't yield fruit. Lord, I pray that for each one of my viewers, you keep drawing them in and help them know that the Lord Jesus Christ is the way, the truth, and the life. And the only way to heaven, the only way to the Father is through Him. Thank you, Lord. Also pray that if any of my viewers are going for anything catastrophic, anything bad in their life, pray that you comfort them, Lord, and help deal with that problem. Thank you, Lord. In Jesus' name we pray. Amen. Cool. So we just got to get up and running again because we got it all compiling and then it crashes. So one or two little things to sort out and then it'll be back up and running again with our simple scene. And then we can carry on. Interesting. Like the paths for the kernel stuff or whatever, the operating system stuff is like the D drive A in the old A folder underscore work. Anyway, good fun. So we crashed in store properties because right, we just crashed. Okay. No biggie. 211. Right. So right, I guess we'll pop in there in the debugger then. Amazing. I bet you it's a null then, isn't it? Can we pee? Yeah, it's a null. So, test one. Yeah, I see. The moss material. Right, that's an easy fix. So the moss material, we can comment that one out for now. All right, and it's completely busted. No. Right, so why is it busted? Well, it's not completely busted. We're seeing things work, kind of. So we're clearly seeing the colors working fine, but then something else seems a bit off, right? We're probably seeing the depth being okay, maybe? Although we don't know the final depth because we're just doing the color, I think. Interesting. Okay, so yeah, something's clearly busted. Let's have a think what that could be. Let's leave that open and follow the code around. So it seems it's obviously shader related. So pop into the materials header. So what we did is we separated out the ray march from the shade. So, oh, did we not set the globals? No, yeah, we did. We set the material property attribute things. So if I were to set this to say 1, does it change something? It does. So things won't be able to be colored properly if dbrick was not right. So things are being colored properly, so dbrick is right. Right, so the half counts, I guess that is the same sort of thing, right? If so, the half counts would be, let's just do a vec3 of 1. Right, so that seems to not be changing much. So, why is it W? Right, so, right, that help, it should change the, make it 28. Okay, so that's clearly changing something there. It's like the coloring, basically. Right, so I think those two are fine. The normal, what else? So it must be the distance itself, right? We render out the hit distance by any chance? So ray march just returns a boolean, but we do modify UV. So I wonder. Right, so we did 3D vector. We will just have the original, we'll just call it O, I guess. The shading.uv. Now we basically just want to return shading UV take original, get the length of that, and that is, you want that to be like a gray, right? Color. So that will then be divided by your maximum distance of maybe, I don't know, 40, I think. Sorry, length. Forward. Okay, so okay. Oh, it's HDR, isn't it? Of course. Right, so we're seeing, this is basically a depth buffer that we're seeing here. So the depth buffer, yeah, it's a depth buffer in object space. Whereas each object has its own one, doesn't it? I'd say it's looking pretty reasonable, right? No? Yeah, it's from when it goes through in object space and it starts at the pixel it enters on. So obviously the bricks are going to be black. Yeah, so I think that means that the ray marching values are probably correct. So then what's wrong? I am now confused. It seems like the number of bricks in that is right. So all the properties and stuff must be fine. We can, the next thing we can try and do is comment out the comment out code until we sort of get these things to disappear, maybe. So might not be this thing, right? Cool. Do 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 do. Oh, there's a normal. Might be something to do with the normal then, but no, we made the normal. Interesting. It might be something to do with the normal. Yes, so it would be great if in debug, well, yeah, it might be cool if we had a way to like see some of this, because we have our textures. It'd be cool if in like the scene shaded image, if we could, well, I guess you can have some debug settings where it allows you to switch out to viewing different things like the normal. But anyway. But yeah, so outside the ray march, we case, we do V, YZW. Do 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 do. Hmm. Interesting. It might not be to do with the normal. Let's say if we always set the normal to be up. What does that do? Or maybe it is the normal. But then why? So I guess what we'll do is an if is mouse at shading dot debug screen coordinate. Print me out the alright, so what we got. We just got a -1, right? Or just, that seems kind of wrong. Then what, a +1. So it seems like how it's trying to calculate the normal ends up being wrong for some reason now. Okay, so what changed exactly? We just separate out the two things, didn't we, really? These do look kind of brick shaped, right? With just a different kind of elevation across, you know, like the bricks have. Where they, so maybe. Oh, the UV. Where's that? Yeah, we need to make a new UV. So how's it doing this again? Calculate normal. UV. You do shading UV times. Ah, right, I see. Yeah, so what we should do is pass in a UV, and then it will do. It'd probably be UV that it changes as well. Yeah, so do some kind of local UV which is going to change, by the way, so we'll let it know that. So UV plus equal that. No, but we should have no, because it's in a for loop. So you want like a UV in, call it. So UV in. It's a super hacky macro, but it allows us to not inline this function, possibly big function like 4 or more times. So it's good. We'll call it UV in, shading UV, or is this? Hey there, JD Husk. Can I ask you for a favor? Go ahead, mate. No worries. Oh. Oh, crap. Oh, okay. UV in and then UV. Too few arguments. Oh. What's this one for? Is this the moss? Alright, we'll do the same thing. Alright, does that work? No ray origin. We should probably comment this out. Screw it. Shading UV. Cool. Right, we're back. We're back. Here's our scene being rendered now. And I guess performance-wise it's still the same. 1 millisecond for shade. Whoops. Yeah, sure, JD House, you can ask for the favor, that's alright. No worries, sir. How a Z buffer works? Sure. So a Z buffer basically, I'll do this all from memory now. So a Z buffer basically, you've got your window, right? You draw a triangle on it. Right, maybe the triangle goes down off into the distance somehow. We can maybe not see that, but That might be how you do. Right, so you got some triangle, right? And it's obviously made up of pixels, right? And when you render a pixel, when you render a pixel in your vertex shader, oh sorry, in your vertex shader, you're gonna have, yeah, it really depends on a whole lot of factors. There's lots of complicated things with how, when and where Z test Z write happens and stuff like this, because you can get like early Z things as well. But the basic idea is in the vertex shader, you define the vertices, right? And then these vertices have your matrix. Where is it? It's the model. You have this sort of projection matrix, and this is going to put the final Z value in the W coordinate. So effectively, the reason why it goes in the W is because the driver will divide by that depth value in there, right? So if it's 1, it divides by 1 and everything stays in the same place, right? But if you, so this would be like 1 still. If you do 2, these will all be 0.5. And so also as well, you got to know about clip spaces and things like, I think there's a good article on this. I'm probably not going to explain it the best because there's like a whole bunch of things. But there's Learn OpenGL on surely there's a depth buffer in here, right? Depth testing, here you go. Maybe this will do. Yeah, I think this will help. Yeah, this helps you. Yeah, this will do it. This is a good article on it. I'm gonna drop it in the stream. Yeah, take a look at that. That will explain it in depth. But the basic idea is if you don't modify the depth inside the pixel shader has the ability, or the graphics driver can decide to do an early Z test. So it won't even run your pixel shader if the pixels don't pass the Z test. But if you change the depth inside a pixel shader, it has to run the pixel shader to figure out if there is a depth there, and then it can write out the final depth value to the depth buffer, basically. And the value in the depth is stored in normalized device coordinates, I think. So it's like between 0 and 1. So it's normalized between the clip in a clip space, I think, or something like that. You have to that's another thing. So that article, it had a conversion function here. So when you read the depth value, it's also stored in GL coord. You have to convert it from that sort of normalized device coordinate space back into a linear depth value. So you do that with your near and far values, basically. Yeah, this will explain it all, hopefully. Um, right, so what's next? Right, is this where the fun begins? We want to try now. Gal Milton. So we want to try and do these detail materials. Now, the way I was thinking about doing them, you have this as your actual surface here. This is the mesh that gets drawn and it gets remarched into here. But we want to draw like moss layers on top, right? So the idea is, I think you can have this detail material layer, and you can sort of define this sort of no problem, sir. You can define the sort of grid of how to lay them down. So it could just be one grid, and there's this sort of like, but then the issue is with that, with the single grid. Yeah, I think you might want a single grid, but then the grid might be like this size, but the ball inside of it will be like half the size, and it'll be able to be offset either that way, that way, that way, or that way type of thing, right? Anywhere inside the box it can be offset. And that means some of them will land and some of them won't. Which does kind of suck. Because how do you increase the density while you might have multiple layers of grids? Yeah. So the question is then, so you got to remarch against these things. Probably. Yeah, we probably are best to remarch. Hmm. The offset thing would be a bit weird though. I mean, our step size cannot be too big when we remarch, and it can get quite expensive. Yeah, so or we could ray trace. So you go inside the grid. So because it's a grid, but then you get the classic voxel stepping issues. But yeah, you could basically voxelize it, and then there's a voxel grid that you're stepping over, and inside that grid there's a ball, and you ray trace to see if you hit that ball. If you do, go in the middle of it, do the distance function to this surface. If it's less than the radius, then we can accept it. If not, no, we carry on. So we carry on with a ray and step through the box, and then be like, right, do we hit the sphere here? Yes or no? Right. So I think that's the basic idea. That will probably be the best way of doing it. Do a ray versus sphere instead. It'll be cheaper. Well, yeah, it'll be cheaper because you're not, and the step sizes there's one ray trace intersection test per voxel rather than tons of them, and then when you go from one voxel to another you're not going to get uh the artifacts where you step too far into the shape. I think that'll be the best way to do it. So the other question is then, if you had these spheres inside these these bounding spheres inside these boxes. Well, you know what you could do is you could actually do a ray. No. So um I wonder if you even need to do the Rayverse sphere at all until you find a grid. No, it's probably the same sort of check anyway. I was thinking maybe you could somehow just do it straight up, do a distance. Then actually the distance is more expensive. You rather miss them, avoid them if you can. Right, so interesting. Okay, so you had your box. Right. So if you had this grid that you're traversing, the other question might be, well, I want to have them more densely placed down. So to do that, you basically have two grids, right, of these sort of that would house a bounding sphere at some kind of offset, right? So you could do another offset grid, if you will, which housed another one. And this would allow some of them to kind of be close together. Yeah, with the potential of having more of them together to kind of thing, that'd be cool. Um, so the question is then, if you were to ray trace through one grid, uh, hmm, you test against the sphere, and then you probably step until the next grid. Maybe there's two grids that you can do. The third grid might be a bit crazy. Just do two grids. Then you go against the second grid. Hmm. Yeah, I wonder if you always want the second grid or not. But also the denseness, if it's kind of like you control how dense this thing can be. But to be honest, if you want to make it kind of dense, would you not do a large grid with a small bounding sphere? Right. So the densest you could make it is a big bounding sphere that matches the grid, right? But then basically there'll be no offset that you could do, so they'll just look very gridded. Kind of. Yeah, they'll look like they're placed on a grid, which is what you want to try and avoid. So by making them a bit smaller, then they can. Interesting. Yeah, so maybe you do another one which is like twice the size, and that's just another. Yes, another that sort of size, but it could be offset or something. Yeah, yeah. So I think, yeah. I just wonder how you'd step through all these different grids and things. Whilst also trying to control how dense. Because you might want to have absolutely tons of them placed down, say. Yeah, you might possibly want that. Tons of these spheres placed down to add detail. I don't know, maybe you can imagine grass or something. Would that be a bit crazy? So, if you want them overlapping, yeah, you might just basically, you know what you'd do, I think? Just do, you do one grid, and then you do another grid, and that grid can just be offset by like half the grid size. Um, and you probably always want this just such that it adds away. So these spheres can go all around that, anywhere inside this box randomly type of thing. Yeah, okay. And the size of the sphere will just help decide how often it will stick to the surface, basically. The bigger it is, the more likely it will stick to the surface. But the less of the more grid-like it would look. Okay. And I wonder if you can do more layers of that. Um, you could also maybe spawn multiple spheres inside of a box. That's the other way around, right? If you just want to make it more dense, you just spawn multiple inside of the same box. That's the other way of doing it. So we can define a voxel size, if you will. How many spheres do you want at what size, right? Maybe they vary in size. And you can then ray trace against them and then be like, what's their distance to the surface each of them or they miss? But then that's an expensive operation, but you are only running it once. Wait a minute. Yeah, and it's not like you're running it on a per step basis like you are in a ray marcher. So you could do it this way around. But I wonder if there's a way where you can say, does this box like mm, yeah, I think that's probably the way to go. Like how big your voxel is, how many spheres you want, and then we can randomize those, step the ray through the boxes. Yeah, let's do that. That seems sensible because that way you can kind of control like your denseness, I guess. Maybe there's two parameters like the size of a voxel, or you can maybe call it It would be nice just to have one slider though, just like a denseness thing. Um, yeah, you could say you could have like a very big voxel, but you're like, hey, spawn like three boxes in here. Sorry, 3 spheres in here at some random offset. Right, and they vary in size. You could do like a voxel size. You could do a Hmm. Yeah, I wonder what sort of parameters we want to expose to the user when they're doing this, right? Because I did just want to paint this sort of stuff down. Oh no, one of these guys. Cool. So effectively we have these like surfaces, right? And we want to be able to like maybe put some moss down or put some stones down. Right, so you want to basically brush them down, right? So when we have this like uh so on the brush or whatever, you could select like what detail material you want, but also like maybe it's denseness, right? So how like dense it is, right? So you might be like, so there might be a few parameters, right? How big? So imagine if you're getting these moss things, right? How big are they? And also what sort of, maybe I should write this down. So you want kind of like a denseness, how sort of, what's the min and max, right? Min, max, max size, if you will, or dim. I guess do size. So what's minimum maximum size of these things you want to be placing down? And then probably like, I mean, they always will just be placed on the surface kind of thing. Um, so I was thinking with say if it's got a bit of moss in there, like an island of moss, if you want it to be like, you might have a brick that just it barely touches and you're like, okay, I will accept this. Right, and that kind of sucks. So maybe what you want isn't, you definitely want an entry, you definitely need like a valid entry position to start ray marching, but you might want to also only accept it providing it goes close enough. But I think that would be a quality or a property which comes from the detail mesh itself and not really the uh, person who's trying to paint it down, right? Because you don't really want a clump of moss hanging off this far, right? Piece of moss which will be in here, this random moss. You want it to be kind of going in mostly, so maybe you want it to be something like that, right? Well, maybe you want the distance to be like quite close to the radius actually before accepting it, maybe. Oh no, because you can't really tell the difference if it's like this. Because your middle would be. Oh no, you'll be in it. Yeah. So, what's the distance if it's less than radius? So if it's less than radius, or maybe it's like how close does it get to here? Yeah, and then if it goes inside. Yeah. So I think that's a property controlled by the right material itself. So you probably want to have a few things right: denseness and min and max. Then how it achieves that is up to the right. So if we just had a denseness parameter, we have a min and max as well, right? So a denseness. So you have min max. Hmm. So I guess the more dense it gets, the more of a grid you kind of want. But then you kind of want to make sure the grid never goes less than like a radius of the uh your max radius, if you will, of these bounding spheres. So yeah, that means the smaller they get, the more kind of dense they would end up looking, kind of thing, I think. Something like that. So the smaller your largest size is, the more dense it shall become with these spheres, if you will. Um, you could also up the number of spheres inside of a volume, or yeah, I think ideally what you want is probably less spheres inside of a volume because more chance you'll miss, less sphere tests to do. But sometimes you'll have to have that as a thing. Um, uh, or maybe there's always four. There's always four spheres, or three maybe. We'll just pick a number. They get randomly offset inside of a box, and the denseness just controls how small the box gets. Yeah, I think that's what we'll do. The next question is then, I think the final one before we can start implementing this, is when you ray trace against these and you hit multiple of them, you'd have to go and step through, try and march into the material in here, see if you hit it. If you miss it, try something else. Yeah, I think that'll work. Cool. Right, so let's try and get this thing actually programmed up now. It's been a bit of thinking to get it work logically sound, but I think it's good now. So right, so we first ray march. Yeah, we first ray march against the geometry material. So after we've done that, so only got one at the moment, it's the brick. We can then now do the sort of detail material. Now, we've got those three parameters that we want, right? Deepness, max, minimax size, if you will. So yeah, um, hmm. So minimax size, where would that? Yeah, so how would this get passed in? So the detail material, it could always have the same header, right? The denseness and the minimax size, that could be like all packed in to the same. Yeah, so detail materials are passed up a little header from the CPU side. And that one, do we want to stick that on a per material basis though? Because what you could do, you can imagine like, hey, I've got like a brush and I'm like painting this surface here. But as I'm going over here, I want it to be a little bit more denser, right? Uh, so yeah, as I'm going over here, I want it to be a little bit more denser. So I sort of like change some of the properties. Now, that might be a whole new material, basically. Yeah. Maybe not though. Yeah, so I think these would just be called, so from the CPU side, so graphics VK is shared, I guess. We'll go into the encoder file. So I think we want to call this we'll call this the detail material properties. So there'll just be something like a so it's a 0 to 1 value, so probably just do an 8. It's normalized, yeah. We'll say, what is your, how denseness, I guess. Then you want to have a probably minimax size. Now, the size would be in UV space, I think, yeah. Well, 0 to 1 will probably be fine. How big do you want it? Um, so yeah, like a min size and a max size. That's all we want for now. That fits into a single U32. There's room for some more. Now, the question is, how do you get this in? How are we going to pass this up through the material system? So, in the material system, we have the potential for some sort of detail property words, and that's in a. So when we but then that means on a triangle, when you store typically just a material ID, you're gonna probably have to have something else. just because it's a detail material. That doesn't seem too great. Maybe you do just make another material ID, but yeah, it's only another U32 though, isn't it? We could probably, because it's, well, wonder if you can store it in the as like a per face property. Yeah, maybe that's how we'll do it, right? So we won't probably care about that just yet. We'll get them passed up. We'll figure it out when we do the meshes. I think we can store as per face property, and that will allow it to sort of stay down in size. And maybe you can blend them as well between LODs and stuff, which could be interesting. That might not work though. It might make stuff look weird. Yeah, you can at least use it to stop it from simplifying anymore, which could work. But anyway, right. So I think that's enough planning. Hopefully we can just go full steam now. So we want this sort of denseness. I guess we'll go inside this sort of thing here. This will be the detail material. So we want to get these properties from elsewhere. So denseness on a 0 to 1 scale, let's just say 1 for now. There's going to be a min and max size. So how do we do this? So I was thinking about the idea of doing the grid, because the grid meant the grid would mean we could test 4 spheres with Rayverse sphere, and every time we hit one, we can just check the closest and then do a distance function to the geometry. If it passes, ray trace into the object, or ray march into the object, and see if we hit the MOS inside that sphere. I think that's the idea. And then if we miss all of those, we just, skip the ray to the next edge of the box, right? So maybe we just do a Rayverse box intersection and find the exit point, right? That will probably be the easiest thing to do. And then keep stepping. So the more dense it is, the smaller the box, and therefore more checks. Yeah, far more checks, right? So I think that'll be cool. So the denseness will describe basically how much do you. It's basically how much of a grid do you want, right? So you have like a grid dim. So denseness is just a divide, isn't it? Is it divide? Or multiply? Yeah, it's just a multiply. So you take. Yes, you have one. How big is your grid cell? Well, it would be the size of the area is 2, and the times by denseness. Okay, that could do it. And then obviously the half dim And sorry, it shouldn't be it should be a float, right? Cool. That's interesting. Then your sizes, they need to be in grid space. So we want to map them into grid space. So when you have a max size of 1 or a min size of 1, right, you want to be able to at least offset your... Oh, hang on a minute. Should it be inside grid space? Sorry, at the moment, the denseness is basically controlling the size, isn't it? Well, not really. Yeah, you don't want it to be inside grid space. We had that option of basically making it such that the denseness would stop based on how big your max size is, potentially. That would kind of suck though. Or not really. Yeah, so... So if you're... So you're probably able to to know a min and max. Well, that's the thing though, isn't it? You might have a wall which goes all the way along here. And if you define it in UV space, that's going to be a bit of a bugger, that sort of min and max size, isn't it? Using bounding spheres as well. Do, 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 do. That means your spheres are going to look quite compacted. Because you've got a very long x dimension. So your spheres will kind of look very squished when perceived in this very long wall. That could be problematic. You know, you could expand. You could somehow be like, well, the geometry material was this thing before, and it kind of said, you know, we actually work on this sort of grid basis here, so remap. Scale out the UV such that it is longer along the X or something like that, yeah. And then do it in that space. And then remap it back into UV space afterward. But then it wouldn't work because we need to do a distance function. So there'd be a constant remap. It would only be a scale though, but still. possible. Hmm. So the geometry material does define. Maybe you have more out parameters. So you do, right? Yeah. I think it's easy to do. We just got to define more out parameters. So I think we'll call it the geometry material out parameters, and it will have a T field, a normal. Right, we'll do some more things as well. We'll call it geometry material out parameters. Ray March out parameters. So the first one would be a T field. How long along the radius step? The next one would be a normal in material space. And the last one would be this new one, which will be like, what is the sort of scaling that you're seeing? Like, for instance, we're doing bricks, right? So what is that scale along the X, Y, Z, such that when you do the detail, materials, spheres still look like a sphere. I think so. So that would be based on the bricks, wouldn't it? How many bricks? Along that wall. Kind of, I think. So out. You can't call it out, can you? Right, so O dot T equal T, O dot normal material space equal N, O dot scale. So that could just be the number of bricks. Um, so maybe you find the max element, and you're just doing that instead. Or maybe this could be part of those other parameters which are stored. No. Yeah. You see, I wonder if the geometry material needs to be stored per vertex anyway, right? Um, because it's kind of a thing you want to probably have per kind of mesh in a way. Because it's specifically designed for a mesh, not ready for a mesh per triangle thing. Hmm. Yeah, I guess we can decide that when we actually make the mesh. But for now, because we've done it on a per instance anyway. Okay, so the scale is probably useful. No, because if the geometry material is per, yeah, I think we should decide this stuff right now. So in the shed, so we're currently storing the material layers in here per mesh instance, right? So I think realistically what you want is the geometry and the detail. So you can maybe say like, hey, this mesh has like, this single detail material maybe. You could do it for the whole mesh, but then that might be a bit limiting, maybe. But then again, if you can paint it sort of per triangle, if you will, that's quite powerful. But the whole, yeah, you probably want them just all per triangle, maybe. So if you did it in that case, you probably would want to return it from the, yeah, let's just do it per triangle for now. So we'll return it from here. So the scale would be basically the number of bricks, a brick counts, divided by the maximum element of brick counts. Obviously, you gotta vector 3 that. So that tells you how to scale it such that right, that's pretty cool. Like that change. We'll call this V, I guess. Right, so V dot T. And then the other one was normal. Nice. So, this is better. So we want to remap the UV now to be in that you might call it detail UV geometry. Okay, that's the surface hit, isn't it? You just take shading.uv. Multiply it by the scale. you might need to be transitioning these around, but that at least solves that problem, where the bounding spheres will now stay in a sphere shape. Cool. So the basic idea would be wanted to ray trace. You've got this voxel grid, and it will have 4 spheres in there randomly offset. And I want to try and size it properly. So the denseness was going to control how big the grid cells are, but then they also need to be. So a simple multiply could work, but then, so if you have a denseness of 0 though, it's going to bring it all the way down to being 0 in size. So maybe, yeah, maybe that's right. So you want to say like, uh, hmm. So maybe grid dim will become whatever it is plus equal. The size is probably a terrible name. What we probably want is radius. Makes a lot more sense. So the radius of one of these spheres, obviously it steps. Yes, you probably want to have it go. The grid would at least need to be max radius times 1.5, right? Because you want to be able to fit a whole. Wait a minute. Sorry, times 2. Or is this times 3? In a minute. So obviously radius is half. The full diameter is 2 times. So we want to go. You probably want like an extra half, right? So that'd be a 3. Yep. There's 1.5 times the diameter. So when it comes to radius though, 0 to 1 isn't going to cut it. So we need to figure out like um um like what's we need to remap it, right, between yeah, we just need to remap basically. The 0 to 1 needs to remap between yeah, so have we got a remap function? That would just be that'd be a lerp, wouldn't it, basically, right? A lerp between want to be an inverse lerp. Yeah, we've not got an inverse lerp. an inverse mix, wouldn't it? I don't think we have one. Mhm. Would smooth step get it? Right, does a clamp, does it? Yeah, maybe. Yeah, maybe I'll just copy mine over. So that'll be in GPU shared. We've got some bits in here. Okay, so that'll be in H maths. Right, inverse lerp. Get the boys in. Cool, so let's get rid of the half ones. Oh, and the 64s as well. Now this would be a vector 2. Vector 3. Vector 4. Right, so just get rid of the suffixes now. Cool. So we've got our inverse lerp function now, which is cool. So we think that we want to produce radius equal inverse lerp. So wait, is that what we want in the end? Maybe it is, maybe it's not. So we've got our value from 0 to 1. Or maybe it's just a standard lerp. Yeah, I think it is. Yeah, it's just a standard lerp. So it'd be like 0 to 1. Yeah, I'm not sure what these values are. But it might be something like that. So that would be like a min radius, a max radius. Cool. So I guess where's the pitfalls with it with this maths here? So if the grid Either denseness is 1, or we're just going to be adding, which isn't really going to work. It's going to make the grid bigger than the area that we have. So the denseness could be remapped as well. The denseness be remapped to whatever. So denseness instead could be remapped to a value of max radius times 3 as the min, right? So then value of 1 and then we won't have to do this. Cool. Very nice. Hang on a minute. So the denseness, would that even be the half dim at that point? Yes, I guess the denseness would be a half dims at that point. Interesting. Cool, good to know. Hey, Buffer. How's it going? Yeah, not doing bad. Doing bad, bit tired, but doing okay. Just, what do we do? Yeah, I think the past, since the clocks have changed, my son's been waking me up a little bit early. Well, before then as well, but it hasn't really kind of made things a bit worse since the clocks changed. But yeah, other than that, not been too bad. But I'm glad it's the weekend now. So, you know, it's a nice long weekend as well because I've got the Monday off too. So it's Easter. Amazing. God bless you too, sir. Whereabouts you been reading from in the Bible lately? What you been reading? Hey, Skosh. It does feel very relevant. Exactly. He definitely rose. And he will be coming back very soon. Any time will tell. Maybe it's tomorrow. Maybe it's next week. Maybe it's next year. We don't know. But yeah, time is ticking. Jesus is coming. It'd be cool if there's a lot of time left. But you see where the way the world is going. You know, the world's pretty crazy. And the world needs Jesus. And the world is going to get Jesus whether it likes it or not. But yeah, good times are coming after some painful times. Revelation, amazing. I love me some Revelation. Such a great book. What yeah, are you what's your understandings on Revelation? What's your where where do you fall on Revelation? Yeah, what's your eschatology, if you will, understanding of it? Would you subscribe to? Yeah, exactly. But you know, some people though would be a blessing for the tribulation because some people actually get saved because of going through the harsh times because that's the only way they'll get saved. But we pray and hope that they don't need that. You know, so you pray and hope someone doesn't have to lose all their belongings to accept Jesus type of thing. You know, you pray and hope they just accept him some other way type of thing. Tribulation looks so harsh. Oh, but it's definitely a blessing in comparison to like how eternity in hell would be, you know, to put it that way. Man. Oh. I think we'll do a for loop. Right, for loop sounds pretty sensible. Maybe just a while loop. Well, you can just do for every grid at that point. Every but then you don't want it to like. Yeah, so if you step, you know what? Yes, I think you want to have like, what is the max? Was that U32 max value that we can do? Want that? So you probably want to have like a maximum number of iterations, if you will. The max iterations will be ooh. Let's just say it's grid dim squared. That'd be too many though. I won't. No, yeah, that's how big it is in UV space. So 2 divided by. No, it's more of a cell. A cell dim. I'm kind of new to eschatology, so I don't have an opinion right now. That's fair enough. Fair enough. Yeah, it's not necessarily. It's not a It's not a salvation issue, right? You can believe. You cannot believe in the rapture. You cannot believe in um anything to do with Revelation being a legitimate book, if you will, but it will still get you. Like, if the rapture's true, you'll still get raptured, basically. But you'll probably have some things to be like, you know, if you took the opinion of like, the revelation was just a dream, you know, God will probably be like, you didn't believe in my word, right? So there'll be some things to answer for, I guess. Like, I spoke to some, there's a member in the family, kind of thing, who's a Catholic, and he was like speaking so much about God and all this. I was like, oh, someone who I can speak to about the Book of Revelation who's a Catholic. I go up to him and ask him. And he's like, well, it was a dream. You know, it's all got lots of like, you know, think you can't take it too literally because it's a dream and all this, right? And but then again, it is the word of God, so you just really just sort of like, yeah, clearly don't want to speak about it too much. But I think some of the Catholics actually think that as well. I've heard it, which is a shame. Yeah, it's a good read. It really helps you, like, when you're trying to understand Revelation, it basically makes you really trying to understand the rest of the Bible because you're like, you gotta understand like Daniel, obviously when Jesus in Matthew 24, Luke 21, Mark 13, right on the Mount of Olives, talks about the second coming. You got there's a Genesis in there and um yeah. Obviously like Isaiah, Jeremiah and Ezekiel as well. Is it Ezekiel? Maybe not Ezekiel. Um, yeah, tons of things. Obviously Deuteronomy and that, you know, with the law and things. Sorry, not Deuteronomy, like the book of Leviticus, I meant to say, with the law and things. But yeah, so many cross references with the Bible from Book of Revelation, which is cool. It really makes you study it. So the max number of iterations. So say if we've got a grid. So how many times does Seldom fit into 2, basically? But isn't that, we're not just like undoing the number at that point? Right, let's try and math this. So if I times it by 0.5, I'm gonna get 1. I need 2 divided by 1, I get 2. So if I did divide by 0.5, so times by 0.5, 0.25, that gets me 0.5. So that is 2 divided by 0.5, that is 4, is that right? Yes, it's not really... Okay, I think that's fine. Cool. Yeah, so basically we cap this out here. And the reason why I do a minimum between these, this max iter and U32 max, is because this is a constant right now, and it would basically be an or it will unroll it knowing the GPU compilers. They're not fun. Right, so this is where the fun begins. So we're gonna have 4. So we'll call this a cell I, if you will, and then we'll have an SI, a sphere I. Now the sphere I, we're gonna do 4. So 4 different spheres at kind of a different offsets based on some kind of seed. That is probably distinct per instance or something like that. Okay, how do you prevent burnout from work plus stream? A few reasons, or a few things. Your main objective is to avoid stress as much as possible. So that obviously balloons out into many things, but yeah, avoid stress. So you kind of also want to, as you're working throughout the day, you need to make sure, like when you've programmed enough for a long time, you kind of have a good instinct and a feeling of like how things go. So you want to spend less time in your thinking brain. So you notice today I've been thinking a lot this stream, planning and doing this stuff, right? So the more stuff you try and picture in your brain, the more thinking brain you're using, and that will basically make you tired. And therefore you will basically not be able to work long times. Obviously sleep is a big thing. Sleep is very important. Avoid caffeine and sugar. Can't even spell it. That's how much I avoid caffeine. But you get what I mean. Whatever. Right. That helps. What else? Yeah, let's think in brain as much as possible. Just try and rely on instinct. Obviously, if you just rely on pure instinct, you're going to create a lot of bugs. So you need to basically like only visit the thinking brain when needed, but don't overstress it. What else? Yeah, you can obviously use caffeine and stuff, but just remember it's a trade-off. Trade-offs, you don't really have to fully avoid it. What other things would you say to work long hours? Yeah, I think this is mostly it. Obviously going outside very much does help, getting a bit of sunlight. Get a bit of sunlight, go for a walk at lunch. If you can. Not necessarily required, but when you go without doing it for like weeks, or at least for me, you notice that like when you go out again, you're like, wow, this is amazing. And your body feels so happy for it. So there's some factor that plays in there. Yeah, but these are probably the things. I don't drink coffee or sugar. That's great. I kind of go in and out of phases of doing that, unfortunately. Let's do that for next time. Yeah, I go in and out of like not doing it and doing it. It's a bit of a juggle for me. Right, where's the rate intersection code? So we definitely need a sphere. There's two versions, right? Right, the alternative method computes h. This is square distance from the closest ray point on sphere with a projection rather than using Pythagoras theorem. This is less precision hungry because we don't generate large numbers in comparison to the size of the sphere. We don't square the edges. This might be the one we want then. Oh, what's this one? Oh, it's just how to use it. Okay. Right, so I think this is what we want. Do you do everything with shaders? Unfortunately not. Well, no, it'd be really crazy if we did. But yeah, no, we're doing materials all with shaders, so all materials with shaders. So this is why we'll be doing yeah. So a lot of the surface stuff and everything, it will be done with shader code. We're not reading from textures or anything. This is why we're doing a lot of shader stuff. You can't do everything with shaders, it's just not possible. Detail material, sphere, Raver sphere. So that'll be a relative position. Is that? Oh yeah. Center position. Yeah, you get rid of that. You basically want to have. Oh no. Yeah, I guess so. So you have your center position. And then your radius. Right, so there's one of you guys. Now we want to reverse box. Ooh. Alright. So you get a near and a far return. Also returns the normal as well. We don't really need the normal. But we can always mess around with this stuff. So detail material reverse ABB. So this box size I think is a half dims. We can find that out. Now we don't need a normal. Yeah, the center's at the origin. So why don't we just do that everywhere? So let's get rid of center pause. OC. Right. So it's also doing a square root. We might not always need to do that. We'll see. Okay, so let's get rid of the normal. Lovely. Lovely. So we want to start off. So you're starting off at our to the grid. You probably want to wind back to the nearest grid cell, if you will. So that would be you first do your array box. So we definitely need a near and a far, but where does the array-verse box go? So either before you do anything, you do an array-verse box to then go back in the detail UV space, if possible, to the nearest. So I guess we could pass in some parameters to be like, oh, you're in grid. So like you want to know basically a grid cell XY, I think at this point. Actually, no, it's an XYW, isn't it? So it's probably not. Hmm. Right, I'll just be back. I'm just gonna get another drink. I'll be back in a few minutes. Oi. Welcome back, welcome back. All right, so we basically have a shading UV where we could be at any point inside of a this box, if you will. You need to be able to locate the start of a box. Or not start of the box, start of a yeah, the start of one of the grid cells. We want to do like a ray versus ABB from your array origin would probably be yeah, so it's relative from where this grid cell is that you're testing as well. So you got to do something. So you got to find what grid cell you're in based on shading UV, and then get the center position of that, and then do an offset from shading UV. So good fun. So what would that be? So given a shading UV and you've got a cell dim, effectively you can write a nice little function for it, I think. So let's put it here, we'll just call it vec3. You probably want to call it like dm cell center position. So for that you'll pass in like, you know, what is the UV and what is the cell dim, or how big is the cell? So effectively it's, is it just UV divided by cell dim? Well, in that case, you might just want an inverse cell dim, right? So would you is it plus, yeah, then plus 0.5, that gets you like, this gives you how many cells there are, but it doesn't really get you the cell center position in, right? Yeah, so you might want to carry around an inverse and a, so cell dim, inverse cell dim, and then you probably also want a, yeah, I think that's right. So you do like a, then plus 0.5. Right, so now you're halfway through the cell, right? Then multiply it by cell dim. So what you'd do is do an inverse, multiply by inverse cell dim, and voila. So what you want is, so inverse cell dim, right, so what's the UV? Well, it's shading UV. So I guess we can shorten that, call it UV, I guess. Oh, it's detail UV in it. Yeah, so detail UV. So detail UV, cell dim, inverse cell dim. Now I think I got that right. Maybe I did it the wrong way around. No, good. Cool. So that will get you. I think there needs to be a round. I think we're missing a round. because it needs to snap. Cool. So this will get you your hit basically. You can call it a box hit, a BH. So your ray direction is just going to be ray direction in material space. Now, actually, though, there is a scale. So you need to scale the ray direction. So it won't be normalized, but that's fine. You'd actually need a ray direction in DS. So that would be spec 3, ray direction, detail space. So that would be ray direction material space times by b dot scale. Yeah, lovely. Right, so the half dims of this thing is just going to be a super lovely cell half dim. Nice. So, right, with this, oh wait, so it's ray origin. So the ray origin has got to be going towards the ray. The detail UV from the from the center of the cell. Yeah. So yeah, we could probably clean this code up a bit. Also, hand optimize it specifically for this use case. That would be great at some point. But let's just get it working. So you got yourself a box hit. So you got the near in the X and the far in the Y. So because it's your first time, you want to check the near. And if the near is less than, or is it positive, or is it, yeah, I think what you want to do is say near, yeah, we want to use the near, isn't it? So I guess you can call it, I don't know anyway. So let's do a near. So that would be detail UV plus equals ray direction detail space multiplied by the BH near. And even if you, or X, that'll be near, isn't it? So even if you go, it will typically go backwards, right? Because you'll probably be starting like inside one of the grid cells, but it will go backwards towards the edge of the box. But it could also go forward as well to the corner of the box, right? So no. No. Because you'll always be inside. No, it's always going to be a back. Yeah. It's always going to be going back because you're always going to be inside. Like, the box it's going to pick is the one which it is inside because it's a grid, right? Cool. So move back. Is that a fair thing you want to do? So you could do the reverse whatever inside of the box. Yeah, you know what? Maybe you don't want to do that. But it's fine because it didn't waste any time because it just goes in here. I don't think we need to do that because if you're inside of a sphere already, you just ignore that one. I think that's the idea. Right, take care, buffer overflow. Yeah, good to see you. And I'll speak to you on the Discord probably, or see you in the next stream. Have a good Easter if I don't speak to you then. Right, God bless you, sir. BH. So you want to ray trace against your spheres, then you want to step to the next box, basically. I think that's the plan. Yeah, so I guess let's do that stepping code and we can do the exit. The stepping code would be if. So detail UV plus equals ray direction detail space multiplied by the bh dot y this time, which is the far, right? You want to step in outside the box. Now, cool. We might want to smudge it over by multiplying it like by a bit of a value. Just nudge it over, you know? But we'll see. I think that'll be fine. Yeah, maybe you want like an epsilon. But we don't know. Anyways. Cool. So basically, if detail UV is outside, I don't know what you want to say. Is it outside the -1 to 1? Is that what we want to say? Then just break. Yeah, I think that's what you want to do. If it goes outside the -1 to 1 range, then do us a break, please. Just exit out. There's no point stepping anymore. It's just a waste of time. Right, lovely. Cool. So now here's where we do the actual checking against those spheres, which could be glued to the surface. So these guys, you want to do that DM reverse sphere this time. So we can call this a sphere hit, so SH. So sphere. And it's basically all the same stuff, except for now, you might have like a kind of an offset. So we're going to work out a few different things. We need to work out the sphere offset, and we need to work out a radius. So the radius will need to be worked out based on some kind of in between of min and max radius, right? So okay, so the offset, like what could be the random value that we use to work out the offset? So we could use just a hash, you know, the you know, that PCG hash thing maybe. We could do that. Since we're in a for loop, we can just keep going. And we initialize the hash value based on the mesh instance. Somehow. Maybe. So there could be a seed that gets passed in as part of the that could be it. So the final value that we wanted was a seed. So having 256, like I was hoping to fit this into like a U32, a single U32, so there's 8 bits left. But if the seed is going to be like up to 256, right? So you could have Or maybe you want the seed to just be completely made up, because like what benefit is it them being the same? Well, you might want them to be the same, right? Might want to clone an object and repeat the object and then align them up together such that the patterns kind of match, maybe? But sometimes you don't really want that anyway. But you definitely want it, like, when you've seen it made, you want it to stay the same, even when you put it down and run it again, typically, right? So, uh, so if you get it from the mesh instance, right, that can change per run, right? What is the mesh instance index? That could be the seed. But then if you move it around in memory, right, it will change its visuals, right, based on its kind of offset into the array. So that's the thing. It could be based on, but basing it on the right. What we're just gonna do is pick a seed. I don't know what, but there we go. Cool. We don't know where it comes from. To do make this unique per something. I don't know what that is. Per something, you know. So we could just do a sort of like a PCG hash, or maybe just do a so I'm using it right now, but there's a state you can keep cycling the state as well. Yeah, this is typically how you want to use it. The pseudo random number generator version. So we have PCG hash. Does it just keep pumping in the input, doesn't it? Isn't that right? So that was input here. And then at the end, I guess the state is just that, right? It's just cycling the state over. Right, so I see. Yeah, so we want to have a way to where's the GPVK shared? Cool, so we would like a PCG hash with state. So state would be in out. So hang on. Let's just do that. Lovely. Okay, so this seed will just keep getting moved basically. So that'll be, so we can use this. So passing seed followed by some kind of value we want to hash, if you will. So I guess you could hash the SI. Yeah, maybe you can tell it to step as well in here. I don't know. We'll see. But yeah, it's gonna change the seed basically, isn't it? So maybe it's fine just to do it like this. So when you can divide this by E32 max, if you will, cast it into a float. We've done this before, haven't we? Somewhere. Okay. Yeah, unpack. We could just do an unpack unorm, right? That's the other way. Like, after all, you really want... Yeah, that's what you want. So unpack. You want to get your sort of random value. That'll just be R. Unpack unorm 4 times 8. Wait, what is it? Okay. And why it's a 4 times 8, what does that mean? So you've got... Oh, it's 8 bits, that's right. Okay, so offset would be XYZ multiplied by... So this is a 0 to 1 value, XYZ. The maximum space we can move is probably max radius. I think it is. Inside the box. And then R dot W times by... So this would be a lerp. A lerp between min radius and max radius. And this would be a 0 to 1 value being pumped into there, obviously. So, that's a nice way to randomize it, I think. And then we do your reverse. Right, so is it already max radius? So, you got your cell. And supports up to 1.5 spheres. Yeah, so that's right. The max radius. Good. So, what you would like to do is provide some kind of like offset. Right, so given the center position of the cell, what is... I guess you'd compute that here. Yeah, given that, can you produce to me... Right. Then you want to apply some kind of like offset. Right, so you want to do like a sphere center position. That'd be cell center position plus offset. Redirection, then obviously radius is just radius. Cool. So now you've got your potential hit, right? This it says a near and a far. So what you're interested in you're interested in a near, which is positive. That's what you're interested in near, because if a near is negative, you're inside it, and we don't want to accept those ones. So this is saying if the So x is near, right? So inside. Yeah. So we want to say if sh dot near is greater, then we like this one, right? So in this case, what I would like to do is, yeah, we should do the distance function to the geometry brick, see if we collide, and if we do, accept it and pick a color and just render it, because this way we'll be able to see it quickly before writing absolutely everything, right? And then that, yeah, this is good. So that would be yeah, so we need to build another function. So we would like to build one where it's like, hey, get the distance for me. Just gotta figure out how to do it. You know, we could, let's not do the distance just yet. Let's, so, right, do we hit it? Therefore, um, so we could say v dot t is equal to sh dot x. Let's just try that out. Although it is gonna move. The problem is it is gonna move. We're going to accumulate a sort of like another t. So bh dot y. I want to accumulate that onto t. So cell I equal max iter or equal u32 max. Vt equal t. T plus equal sphere near. Alright. Oh, I think that'll do it. Oh, that was a piece of work. Alright, what's going on? Now, what's this complaining about? Probably the inverse lerps, no? Okay. In out U32. Nothing called box size apparently. Half dims. Yeah, that's right, isn't it? So seal, round up. All right, so we got absolutely no hit, I think. But we can see... we can poke in and see what values we get. So a good place to start would be... so if is mouse at shading dot debug screen coordinate. There we go. So we're here. Can you print me out maybe, you know, how big is a cell? You know, how big is a... you know, what is the v dot scale thing, right? Can we see those? Right, so the scale is 1. Right, that makes sense. Because it's even each side, you know, so 5 by 5 by 5, so that's fine. And then it's got a 2 for the cell dim. Because the denseness is 1. So 1 cell. Hang on. Is the denseness the denseness... yeah, it's the wrong way around, isn't it? So denseness equal 1 take denseness. Dense. No, hang on a minute. 1 take denseness. That's not denseness anymore. That would be because something is... what would you even call that new value? It's not really denseness anymore. It would be what's the cell half dim, isn't it? The 0.6. So cell dim is 0.6. So what does that mean? Well, the max number of iterations then is 4 for some reason. So yeah, it's about 4, isn't it? Yeah, but you probably want to square it or maybe times it by 1.5 if it's times it by 3 maybe for 3 dimensions. I don't know. That sounds a bit weird. Okay, let's try that. Because if you go diagonal through a box, you'll at most hit 3 different boxes, I think. But then diagonal... right, so if you have a grid of 5... have a look at this. So you have a 5 by 5 grid, right? So this is 2D. So if you're going down here, you'll go and hit... you're likely to hit this side, so it's 1. Let's step through it diagonally exactly, so there's 5, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's basically times 2. 1, 2, 3. Yeah, so I think it's about times 3-ish. That'll be fine. So, because it's 3 dimensions. So, max iterations is 12 now. That's cool. So that's a better number. So, you're iterating. I guess let's look at your cell. Let's go for here and just do that scale there for 1. And then we can do like, hey, what is your... So we'll do a cell I plus 1, the hex ID. Then we can pass in a cell center position. Right, so the cell center positions are what exactly? So we just got the 1, and it seems to be doing a 0.3, 1.5, and then a minus 0.3. So that's not very nice. Is it? So we seem to have gone out. Well, oh no, we did a 1.5 on the Y. Oh, this checker seems to be stopping it. So we need to convert this back into geometry space. So we do that by dividing it by v.scale. Right, so that should give us more iterations now, no? I don't know anymore. So let's check. This one will do a 0. Oh no, 0.2. We'll do it. Oh, hang on. Right, so let's do a third one, and that'll be a... Alright, so yeah, we end up even worse place. Minus 1.5 and positive 1.7. Those are not good. How do we end up there? Shading UV. It'd be interesting to know what shading UV was right away here then, or detail UV. Yes, this is shading UV. Surely that ends up being on like, yeah, it ends up being 1 at the top, right? It was here 1. That's fine. They're in the -1 to 1 range. When we multiply it by the scale, so let's make that a weird long number so we can tell which one it is. Oh, you don't like that apparently. V.scale. So, oh yeah, it's obviously just times in by 1, right? Because of, yeah, okay, so something else is the problem then. We need to try non-uniform bricks, but there we go. So cell center position, that's fine. Modify the detail UV. Maybe it's the BH. What is the far? It's a -1. So that means there's a clear problem in the ray. So -1 means no intersection. Oh, that would be nice. So if... Right, so we didn't handle those. So, right, if there's no intersection with the boxes, then... Oh, weird. Oh wait, I'm going towards the ray from the box rather than to the box from the ray. I think that's why. Oh, which way around is it? No, it is ray origin, take that. Yeah, it's all around ray origin. Alright, so why you no work then? So I guess we pass in a few of the parameters. Test them out. Okay, so got 3 and a 4, so detail UV. Yeah, so it's got a 1, so it's the 3 here, right? It's got a 1 on the Y, so it's coming in from the top. Now 4 ends up being a 1.5. So, right, so because it's at a 1, it ended up rounding it up to the cell size, which is outside of the box. Wrong way around. So I think what we want to do in that case is slightly shrink the UV by just a smudge. Cases like this. So we want to shrink it by a little smudge. Nope, still rounded it up like a bugger. Yeah, rounded it up is why. The reason is because my cell center position function is wrong, right? I just maths wrong. The plus 0.5 needs to be in the before the round, I think. Oh. So divide the UV by the cell, the size of a cell, then plus 0.5 because you're saying right half a cell, or you can say plus 1 because it's in sign norm space. Man, it's so confusing sometimes with sign norm stuff. So yeah, in that -1 to 1 range, how many cells are you fitting in? So oh, I was at the time already. Right, I'll probably put a pause in it here, but tomorrow there'll be a stream. We'll do 2 p.m. 2 p.m. tomorrow, and we'll stream for a few hours, and hopefully we'll get some of this working tomorrow. We should at least be seeing some debug spheres on the surface of this box, right? And they'll be touching. And then from there, we'll be able to ray trace into those spheres and then do whatever custom shape we want, like some moss material or something like that. I wonder what's the perf like. It's not really a good test, to be honest, actually. we've got to wait. But I wonder how bad of a performance this is going to add. But it is ray tracing rather than ray marching, so it should be better. But yeah, we just want to be careful. We are doing a lot of lerps and stuff though. We'll see. Maybe we'll reduce this to two spheres per grid cell, but we'll see. We'll see how it goes. But yeah. Right, so in the meantime, guys, there's a Discord and we come and chat and hang out. And then there's also, if you want to support the stream and get access to the codes running your own local machine, you support the channel via Ko-Fi as a membership there. Right, so hopefully I'll see you all tomorrow. But yeah, I hope you all have a lovely time, a lovely Easter if not, and I'll catch you later. Right, God bless you all. Bye-bye.